All right, everybody. Again, I am sorry that I could not be in class today, but was unavoidable. So we're going to walk through the notes together here. I want you to put some effort into watching this video, trying these problems, thinking about what you see here, and please make sure you come with any questions tomorrow. The plan is the quiz will be on Friday. There will be problems similar to the problems on the second page here on the quiz, just like there are on the homework for this unit. So if we take the time to put the effort in today and ask questions tomorrow, I think we will be just fine. All right, so quick review here. What we talked about previously with sine, cosine, and tangent was that if we had an angle measure on the unit circle, right, and we were to treat the horizontal and vertical distance from the origin to the point on that circle created by the terminal side, which would be xy, that x would be the horizontal distance and y would be the vertical distance. Now, since it's the unit circle, we know the radius is always 1. Because the radius is 1, which we do know the radius is the same thing as the hypotenuse of this right triangle, that makes it very easy to find sine, cosine, and tangent. Sine was y, cosine was x, tangent was x over y. We did that previously. All right, but what happens if the circle we are working with is not the unit circle? What happens, and I'm just going to draw this first quadrant of a larger circle here, what would happen if we extended the radius beyond 1? All right, now this nice dynamic of our hypotenuse being 1 in this right triangle, right, in the blue right triangle, hypotenuse is 1. You can see in what would now be this red right triangle, hypotenuse is larger than 1. The hypotenuse, the radius, right, which we didn't have to worry about in our trigonometry because it was 1, we now have to take into account. So what we're going to be doing in these notes is learning how to work with our trig expressions in with right triangles inside our unit circle when our radius is not 1. In other words, we're making our unit circle bigger. How do we still work with sine, cosine, and tangent? All right, well, you're going to see it's really not hard, especially if right triangle trig back in the day in geometry was something that you know you were proficient at. All right, so there's my circle. Now we don't know what the radius is at this point in a circle. I apologize, I know it's not an awesome circle, but it's the best we're going to get. So the radius is no longer 1. The radius could be 10, radius could be 100, radius could be 25. We don't know what the radius is, but what we do know is for any angle measure, there's still going to be a point that the terminal side creates on the circle. And the vertical and horizontal distances that give us that point are still going to be represented by x and y. So instead of thinking of this right triangle in SOHCAHTOA terms, opposite, adjacent, hypotenuse, we're going to think about it in terms of x, y, and r. So what that means now is that the sine of any angle measure is going to be y over r. Now the reason in the unit circle we never had to worry about this r is because r was always 1. Y divided by 1 is always just y. Now since r can be any number, well, positive number, right, we have to reaccount for that in finding our trig functions. Cosine of theta would then be x over r. Now tangent is nice, since tangent, calculating the tangent of an angle does not incorporate the hypotenuse of the right triangle or the radius of our angle there. There's going to be no change there. All right, so essentially what we're doing is we're going to take our unit circle, which was just sine is y, cosine is x, and tangent is y over x, and we're going to then expand that unit circle to some radius larger than 1, and that changes my trig functions by making the denominator of sine and cosine a value we actually have to account for. But the properties we're using to get these guys is exactly the same thing you did in right triangle trigonometry. So let's take a look at several examples that apply this. So we have a point 7, 24, and that is on the terminal side of an angle measure. So we know our 7 is x and 24 is y. So the question now becomes, how do we find r, right? If I know x, y, and r coming back here, I can find all three trig functions pretty easily for that angle measure. So since they give us x and they give us y, we need to figure out what r is. So if we go back to, sorry, let me scroll up here. If we go back to a couple of notes ago, right, we started working with the Pythagorean theorem in terms of x and y. Now back in this time frame, it was x squared plus y squared equals 1 squared because the radius was 1. Well, now the radius is no longer 1, the radius is r. But we can use that same relationship to say that x squared plus y squared is going to equal r squared, right? So x is 7 plus 24 is going to equal r squared. All right, now 7 squared is 49, 24 squared, sorry, let me get my calculator out here. And 24 squared, hopefully you're already done it on your own, much faster than I'm getting my calculator out here. And 24 squared is going to be 576. So 49 plus 576 is 625, right? So we can see r squared equals 625. So we take the square root of both sides, and r is going to equal plus or minus, I believe it's going to be 25. Let me just double check to make sure I'm giving you accurate information. Yes. Now here's the deal. Can the radius of a circle have a negative value? And the answer is no. Radius is a distance, an actual measurable distance, and measurable distances cannot be negative. So even though solving this equation gives me positive and negative, r is really just going to only be taken as positive 25. So now I know x, y, and r, so we can now use the right triangle relationships that we had to find sine, cosine, and tangent. So sine is y over r, so that's 24 over 25. Cosine of theta is x over r, so that's 7 over 25. And the nice thing about tangent is that's just the same we've always had, which is y over x. So we would get 24 over 7. So you can see in this first example, we were given an ordered pair, we were given x and y. We used our Pythagorean identity here, that we know that the x squared plus y squared equals r squared in our unit circle to figure out what r is. And once I know x, y, and r, we just plug in the values to find sine, cosine, and tangent. All right, let's take a look at a problem that gives us the same information, but it gives it to us in a slightly different way. So in number 4, we're not given an ordered pair. What we're given is cosine. So the question is asking for sine, cosine, and tangent, and the problem does one of them for you. So that's nice. We really only have to find what is sine of angle A and what is tangent of angle A. The other piece of information they give you is that we are in the first quadrant. Now, why is that important? Well, going back to our unit circle, in the first quadrant, we know something about the values of x and y. We know in the first quadrant, x has to be a positive number, and we know y has to be a positive number. Sorry, hold on, let me rewrite that. That was a little sloppy there. It has to be a positive number, and this is going to affect the values we choose for x and y, depending on what quadrant it is in when we calculate this here. So, so when we take this here, what cosine of angle A is x over r, right? So if we compare these two, that's telling me x is 5 and r is 12. So the real question here to answer again is, what is y? Well, we're going to use our Pythagorean identity here again to figure this out here. So x squared, 5 squared, plus y squared is going to equal r squared, right? 25 plus y squared equals 144. Subtract here, what are we going to get? We're going to get 119. Take the square root of both sides, and y is going to equal the square root of 119. Notice not negative square root of 119, just positive square root of 119. And we would expect you to simplify that radical, but the square root of 119 is fully simplified, so we don't need to do any work there. So now again, let's just come to our angle measures here. Sine is square root of 119 over r, which is 12. Cosine is x over r, which we saw was 5 over 12. And our tangent is y square root of 119 over x, 5. All right, so you can see in both examples, essentially what you're being given is two of the three variables. You're either given x and y in example 1, you're given x and r in example 4, sometimes you'll be given y and r. You're going to be given that in example 5. The key is use the two variables you have with our Pythagorean identity to find the third, and then plug them in. I will do the rest of these 4 problems. I'll show you all of my work in the notes. I'm not going to walk through them in the video because you're probably already sick of listening to my voice. So I will sign off now. Please look at these. Please check the notes in real-time board here to check your work. Please, 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 guys, if you have questions, come to class on Thursday ready to ask them. And we'll talk about whatever we need to talk about to make sure we understand extending the unit circle beyond a radius of 1. Have a great day.